Very good morning, children. In the last class, we have discussed about the parallel and series circuits of the cells and bulbs. Okay, and here on the basis of that, some questions they have given. What are those? Why does the bulb glow brighter and brighter when electric cells are connected in series? So what will happen while the bulbs are connected at that time in series? That is different case. Here what they have given, when electric cells are connected in series. When electric cells are connected in series, if we attached one cell at a time, so if we include another cell, so at that time what is the change of the voltage? 1.5 volts per each cell. So at that time the voltage will increase. Due to the voltage increasing, the one bulb only we are connecting, and see in series we are connecting cells. So more voltage is coming, and throughout the circuit same amount of current, same voltage of current will pass. So that's why in series connection of cells, the bulb will be brighter and brighter, like that. Actually in parallel only it will be brighter, but in the case of electric cells are connected in series, I am telling, electric cells are connected in series, more cells, more than one cell here. At that time the voltage will increase for each cell. For heavy voltage the light will be brighter. So here we are using only one bulb and cells are connected in series. So due to that heavy voltage, the bulb will be brighter and brighter. And the next question, do the electric bulbs used in your house glow with a dry cell? Why? No, those electric cells, dry cells. Yes, electric bulbs needed high heat of filament, high heated filament. So due to the heated filament, due to the electric current, the filament will be heat, and then afterwards the electric bulb will glow. And coming to the dry cell, it is just enough for torch light. It is not useful for electric bulbs. Yes, dry cell is enough for torch light. That is sufficient. The amount of current generated by dry cell is enough for only torch cell. That is sufficient for the torch light. And coming to the next question, are the cells used in torch light and wristwatch the same? Yes, sometimes in torch light also that button type cells they will use. Yes, button cells, small in size they are. And sometimes we'll use the carbon and zinc made up of, yes, zinc coated and carbon inside, positive and negative terminals, like that dry cells type. Those type of cells in cells we are using in torchlight. At the same time, in some torchlights button type cells also they will use, and wristwatches always button type only they will use. Yes, so in that manner the change is there in size of the cells. Two types of cells we can use in torchlight, but in the wristwatch only button type of cells. And fourth one is, what is the reason for connecting electric bulbs in parallel in a household electric circuits? Why we need this? For parallel connection, here we are using parallel connection in our household electric circuits. Why we are using like that? So for this once I will show you the reason for the parallel connection is that it results in each appliance operating at the same voltage. So each entire current is passing throughout the same current passing throughout the circuit in the case of series connection. But in the case of parallel, just a minute, I will send that also. Yes, just a minute, just listen. Parallel connection is result in each appliance operating at the same voltage, Nana. And in the case of series, what will happen? Same voltage passing throughout the circuit. If we are using number of bulbs, more number of bulbs, the current quantity will decrease. The brightness will decrease at that time. Here the current is sharing for all. Same voltage will pass to the all. So that's why in the case of parallel, it is happening like that. Same voltage for all the objects or all the bulbs. So that's why we are using parallel connection in our household. This one I will present you now.
Next we have heating effects of electric current. So when the bulb becomes hot, the filament inside will be heats up. So due to that current flowing through it. So this concept involved in so many electrical appliances in our home. Those are electrical iron box we are observing in our daily life, electrical cooker and electric heater. So these all are containing the coil called nichrome. So this coil is called a filament of that appliance. So due to that heating of the filament, we are getting the heat energy due to that. So in that manner we are using so many types of electrical appliances made up of filaments. So we are converting here electrical energy into heat energy in the case of electrical iron, electrical cooker and electrical heater. And in the case of electrical bulb also we are using filament. So next we have the lights and compact fluorescent lamps. So what is the difference? In the case of fluorescent bulbs, ionized gas is used, and in the case of electrical bulbs, filament is using. What is the difference between a compact fluorescent lamp and a tube light? So for that I want to show you screen sharing I want to give you now. Here we have electrical bulb glows when electric current passes through its filament, and at the same time the small amount of electricity produced by one or two dry cells can light up only a small electrical bulb like torch bulb. It cannot light up the big electrical bulb. So that means here dry cells are not suitable for electrical bulbs. And in the case of here, the differences between electrical bulb and a compact fluorescent bulb. Here they have given. In the case of electrical bulbs, filament present in the bulb, and in the case of CFLs, that means compact fluorescent lamps. So there ionized gas is used. Here see children, ionized gas discharge through an ionized gas in the case of CFLs is happening. And while coming to the tube lights, yes, compact fluorescent bulb and fluorescent bulb. Now what is the difference? Most compact fluorescent lamps have an integral ballast that is built into the light bulb, and in the case of fluorescent tube lights require separate ballast independent of the bulb, and these CFLs we can use and we can place in normal electrical bulb holders. And these type of tubes, fluorescent tubes, we need specialized equipment, a frame we have, a specialized arrangement, a set of arrangement we have to use. Yes, so that is the difference between fluorescent tubes. Those require separate ballast, and in the case of fluorescent lamps, CFLs, an integral ballast inside, so that's why we can place that in normal holders. CFL bulbs, fluorescent bulb lamps, we can place in normal holders. In the case of tube lights which are made up of fluorescent, that means ionized gas made those bulbs, those type of tube lights, separate ballast that is independent of the bulb. So both are giving efficient light only, and there is a saving of current also, both of these. And LED tube lights also there children, and LED tube lights can provide a much more directional and therefore effective source of light. There, rather than ionized gas, LED light emitting diodes used in LED tube lights. So in that manner we can understand all these differences between electric bulbs, fluorescent bulbs, and electrical bulbs and tube lights. Yes, while comparing to the electrical bulbs, these all are pure fluorescent and LED tube lights will give efficient light and also those saving current also. Here is electrical fuse. Yes, the next topic is electrical fuses. Actually, fuse is a small thin piece of wire, and it is made up of a specialized alloy that gets heated quickly and melts quickly. So actually fuse is used for safety purpose. So when the appliances may get heated, they can catch fire and they may damage. To avoid that, a safety device we are using, that one is fuse. So here it is a small thin wire made up of an specialized alloy, and while the overloading of current, overheating will happens, means at that time this wire will melt and the circuit will break, so then the electricity will be stopped. So due to that, there is a protection between the appliances. Protection of appliances happens. We can protect electrical appliances by using fuses. So it is a safety device. So this is the oldest one, and nowadays we are using miniature circuit breaker. In the place of that electrical fuses, miniature circuit breakers are using. So it has a switch which goes off automatically. There is a overheating. There is a switch. When overheating happens, that switch will be off, and again we have to on. So here this is automatic process. While comparing to the fuses, each and every time we have to place fuse again. And this is a single operation. Fuse need not be replaced here. And after every single operation, we can on that switch. So, but in the case of electrical fuses, every time we have to replace. After every single operation, we have to replace the fuse. So, in that manner, this is the advantage with the miniature circuit breakers. And there is a disadvantage also for this. So, I will show you that as screenshot now. Here see children, due to the miniature circuit breakers, we can get high temperature. There is a chance to change in temperature. So due to that change in temperature and rising temperature, there is a susceptibility. That means harmness is there for electrical appliances. So due to that, the electrical appliances may damaged, may be bending, and it will take larger time than fuse to off that, and it needed higher energy to off that switch. To break the circuit, higher energy needed in the case of miniature circuit breakers. That is the disadvantage. So here higher energy needed means the electrical appliances may be damaged. They may bend. So metallic appliances or any other electrical appliances may be damaged at that time due to the higher energy requirement. So and for breaking circuit, here lot of time taking and lot of energy needed. So those are the disadvantages due to the miniature circuit breakers. There is a lot of temperature rising. So due to that, there is a chance to damage of the electrical appliances which are placed in that circuit. For breaking of circuit, overheating at the overheating time, we need lot of energy. So at that time, the appliances may get damaged. So this is the disadvantage, children. Just understand this one. And the last topic in this lesson is electricity in our home. So we have digital meters nowadays in our home, and how those electricity department people will calculate that electrical units whatever we are consuming in our house, and how the household and commercial purpose electricity is charged. So these all are also you have to understood. Actually we are using alternating current in our daily life. Yes, alternating current we are using rather than DC current. So in our household purpose we are using alternating current. Alternating current means the magnitude of the current will change according to the time. In the case of direct current, the magnitude of the current will not change according to the time. That means the direct current is used in smaller level. If we want to use higher level of current, at that time alternative current is useful. So in the transformers, all we are using alternating current only. In automobiles, in small level of usage, at that time only we are using DC currents. Those also I will show you now. And one more thing I want to discuss with you in the last of this lesson. That one is how they are charging, how they are calculating our electricity bill. So in that manner we have to understand. I think you observed in your daily life electricity bill you observed. So in that what they will give children? 40 units, 20 units like that they will give. 1 unit means kilowatt hour. Kilowatt hour. So how they will calculate those means, for example, here one example they have given. So from this you can understand. In a house there are 4 bulbs, 100 watts bulb, and 60 watt bulb and 40 watt bulbs they are using. 40 watts wattage, due to the wattage the units will be increased. So 100 watt bulbs are 4 they are using, 6 are of 60 watts and 6 of 40 watts. So like that we have to calculate 4 into 100. Yes, 4 into 100 watts and 6 bulbs are of 60 watts. So 6 into 60 and plus 6 into 40. 6 bulbs are of 40 watts. Like that manner, and we have to add all these. So then we got 1000 watts. That means 1 kilowatt. And how many hours we are using these all bulbs? 2 hours, 4 hours, like that also we have to consider. If 2 hours they will be used, so they will be used 2 hours daily. So at that time 2 hours into 1 kilowatt. Daily they are using 2 hours, that can 1 kilowatt of current, wattage of current. So in that manner we have to multiply. So we got here 2 kilowatts per hour. 2 kilowatts hours. So here we have to calculate these for entire 30 days. So we have to multiply 30 with this. 30 into 2. So I'll get 60 kilowatts hour. That means 60 units. So for unit charge we have to calculate the amount. For unit, for example, per unit 2.8. 2 rupees 80 paisa. So we have to multiply, then we'll get 168 rupees. In that manner those people will calculate. Electricity department people will do like that. So in this manner we are paying our electricity bill. Thank you, children.